All right, then we have covalent or molecular bonds. These are completely different than your ionic bonds. Ionic bonds, they're transferring those electrons from one to the other element, and then they're held together by the positive and negative opposite attract force. What happens in covalent bonding? They're sharing the electrons. So it happens between two or more nonmetals. So if you see two nonmetals in a compound, it's most likely a covalent bond. Some nonmetal elements exist as diatomic molecules in nature. So you have 7 diatomic elements: H2, N2, O2, F2, Cl2, Br2, and I2. Pretty much they want to be in groups of 2 if they're by themselves. So they are always in a covalent bond because they don't like to be alone as an ion. The name of those covalent bonds is just simply the element name. So Cl2 would just be chlorine. You don't have to specify that it's something else or use chlorine chlorine or chlorine chloride. You can just say chlorine. Covalent molecular bonding can form multiple bonds between two atoms, so you can have single bonds where they share just one pair of electrons or 2 total electrons. You can have a double bond, which is where they share 2 pairs of electrons, which is what is shown in this diagram down here between carbon dioxide. You have a double bond here and a double bond here. So they're sharing 4 total electrons between them. And they can also share triple bonds, where they share 3 pairs of electrons. Your triple bonds are the strongest. Obviously, the more they share between them, the closer they're going to be and the stronger they're going to have. Stronger it's going to be holding them together. And then obviously, of course, single bonds will be your weakest. There are different shapes. It's called Vesper theory, valence shell electron pair repulsion. You pretty much look at the valence electrons and how a pair of electrons repels other pairs of electrons in the molecule, either shared in a bond or unshared electrons, and then that determines the shape of the molecule. So these covalent molecules are going to have different shapes that they'll be bonded in to form different things. So for example, we have linear, where they just be straight across. We have trigonal planar, where they form a triangle with the central atom in the middle. You have bent, where they kind of look like an upside down V. You have pyramidal, where they look like a pyramid. There's 3 bases to your pyramid. They're all meeting at a peak. You have tetrahedral, which is where you have 1 central element and 4 around it, and they're evenly spread out as far as they can. So it kind of looks like either a walking man or a pyramid with an extra peak at the top. We have trigonal bipyramidal. So pretty much what you see here is we have a triangle in the center, and if you drew lines on the outside of all of that, it would look like you had a diamond. So you'd have a triangle, you have a pyramid here, and a pyramid there. It's like 2 pyramids back to back. Octahedral, we have a straight line, a central atom. There's 4 around that central atom and then 1 out each side. And square planar is pretty much the octahedral, missing those 2 up the top and the bottom. You just have a square around the outside around a central atom. There's a couple other shapes. One other one that you probably want to learn about is a T-shaped. It literally just looks like a T. There's 3 straight across and 1 coming down from the bottom. There's different polarities of those covalent molecules. A polar bond is formed when electrons are shared unequally between 2 atoms. So pretty much electrons in covalent molecules are being shared, but they're not always having shared custody. Some might get more custody than the other elements. So when they have a polar bond, one of the elements is getting more share of those electrons and is pulling it closer to it than the other one. This has a slightly positive side and a slightly negative side because of that. The more electronegative atom, remember electronegativity, they really, really want electrons. The one that really wants electrons more is going to pull them in stronger than the less electronegative atom. And that's how we have a polar bond, like down here in this picture of hydrogen and chlorine. Chlorine is more electronegative than hydrogen, so chlorine pulls more of those electrons and more of that electron cloud towards its side. A nonpolar bond is formed when the electrons are shared exactly equally. That's usually seen most often when you have the exact same element bonded to itself because it has the same electronegativity. So for your sake, to find the polarity of molecules with those multiple bonds for our covalent molecules, it's going to be polar if the molecule has polar bonds that do not cancel out due to symmetry. Some molecular shapes always produce those polar molecules like bent, pyramidal, and T-shaped. So if they're not all the same element bonded together and they are bent, pyramidal, and T-shaped, they're going to be a polar molecule. If they are a tetrahedral shape, if they have the same elements around the outside, then they're going to be all canceling each other out. so it's going to be nonpolar because all the bonds are either nonpolar, so the molecules, all the elements are the same, or if they have polar bonds, in the case of this one up here in the top right, but they cancel out due to symmetry around the central atom. So we actually have a decision tree to help you figure out polarity of the molecules to make this a little easier. But just know that if you have all of the same element bonded to itself, it's going to be nonpolar because all of your bonds are nonpolar. It's when your bonds are polar that you have to pay attention. So if the molecule has polar bonds and they make a certain shape where those bonds don't cancel out, it's not symmetrical, or you might have different elements bonded around the outside atoms or around the outside of the central atom, but it will be nonpolar even if it has polar bonds if the whole entire compound is symmetrical in shape. So we do have a decision tree that makes that a lot easier. Here's exactly what we actually use to calculate electronegativity and the type of bond. You don't have to worry about using these molecules to figure it out. For our sake, they're going to be nonpolar if it's the same element bonded to itself. Polar bonds if they are two different elements, but they're both nonmetals. And then our ionic bonds, remember those are the first ones we learned about, when you have a metal and a nonmetal and they have an opposite charges and use ions. So that's how you guys will tell the difference between those. So the properties of your covalent molecules, they can be solid, liquid, or a gas at room temperature. They generally have lower melting and boiling points than ionic compounds. Remember, they have really high ones. Most are non-electrolytes, so they don't conduct electricity when they're melted or dissolved in aqueous solution. And their properties are based on their structure, so the shape, number and types of bonds, and the attraction for other molecules, if they're polar or not. That affects their properties.